Benchmarking. They've written out for you the first 10 perfect squares right here. Those are the same ones that I have on the board. Then they've written up the perfect square, or the square root of it, which matches right below. So they're telling you that if you square root the top number, you'll get the bottom number. Looking at this, it kind of makes sense. That means the square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4, and so on and so forth. If we want to benchmark something, benchmarking just means estimating. You find where it would be on the squares list. So the first question is, benchmark the square root of 11. If I wanted to benchmark the square root of 11, I would take the number 11 and figure out where it would be on my square list up top. 11 would probably be right in here, right? Pretty close to 9. So if I wanted to benchmark the square root of 11, I would be in the same space on the square root. The square root of 9 equals 3. The square root of 11 would equal what? 3.1? Right? Just past 3. So then you can actually just ballpark or benchmark or estimate whatever word they want to use for roots. So the square root of 11, I'm going to say is 3.1. As long as you're within 2 decimals, like you don't have to be spot on, you have to be within a couple, I'd be happy. So if you said it's probably 3.2 and you felt it was a little bit more, that's fine. Said 3.4, I might give it to you. 3.4 is probably a little bit more close to the middle of the line. Like you can see the square root of 11 is right next to 9. So I want to try to pick a decimal that's really close to 3. 4 would probably be more close to the center. But it's probably still close enough to get you the answer. If you started saying 3.5, 3.6, 3.7, you're on the wrong side of half. Right? You're going to be off.
Oh, I found the actual answer.
What did you get for the actual answer?
3.3.
3.3.
3.3.
So hey, so 3.4, you were closer than me.
You know why? Because 3.3 times 3 equals 10. So like.
Oh, I like it. Actually, that's super smart.
So roughly, if you're going to 11, it would be like 3.4.
I like it. That actually is very logical. And that's all estimating is, right? Like, no, I don't think so. That was pretty spot on and a really good argument of why it would be that. So all you're trying to do is get close. Like you're not trying to get spot on. If you're within 0.2, I'm happy. So like I said, anything above 0.5, I'm probably not liking. 3.6, 3.7, 3.8, not a fan of. Anything close to that, I'm happy. You got a question?
Yeah. So what would be 11 if you think it's perfect square?
So 11 is between which perfect squares? If you're looking at it, I'm just going to erase this markers.
Or would it be 9 and 16?
The square root 11, or 11, is right here. It's in between the perfect square numbers, 9 and 16. Because it's in between 9 and 16, square root of 11 should be in between square root of 9 and square root of 16, which is how we estimated, right? These are basically just notes explaining what I just did. Square root of 11 should be between square root of 9 and square root of 16. Square root of 9 is 3. Square root of 16 is 4. So the square root of 11 should be somewhere in between. And it should somewhat match up with the distance away from the other perfect squares. It should be closer to 3 than 4 because 11 is closer to 3 than 4. That's our next sentence. 11 is closer to 9 than 16. Therefore, the square root of 11 should be closer to the square root of 9 than the square root of 16. And therefore, let's use 3.3 as our estimate then, because we know what it is. Therefore, the square root of 11 is 3.3. An estimate of the square root of 11. We know that's not the actual answer. Yeah.
So would it be 8.3?
For square root of 78?
Oh, that's no.
3.3. Do you want to come sit back up here? Would that help?
No.
No? Okay. I'll try to use dark colors. Okay, so we try the next one. It says 78 is between the perfect squares. So we go up here, and we're going to look for the square root of 78 to estimate it. I'm square rooting 78. 78 is pretty close to 81. The square root of 81 is 9. The square root of 64 is 8. Therefore, the square root of 78 should be about 8.8. That's what 8.8. Right? It should be pretty close to 9. It's not going to make it all the way to 9, but it should be really close. And my goal is to be within 0.2. Down here, we're going to just fill in the blanks of what I just said. 78 is in between 64 and 81. Therefore, the square root of 78 should be in between the square root of 64 and square root of 81. Therefore, 78 is closer to 81 than 64. So the square root of 78 should be closer to the square root of 81 than the square root of 64, giving us our estimate of 8.8. Taryn, did you actually do it?
8.8. I did close.
Oh, sorry, not Taryn. Yeah. All right, sorry,
It was
Taryn.
8.8.
It was 8.8
Oh, without all the next.
with a lot after. Yeah. So again, we're just close. And you'll never know it exactly because most of these square roots create something called irrational numbers. You don't need to know that. But an irrational number goes on forever. So you'll probably never get the exact decimal because most of these decimals, they go forever and ever and ever and ever. So you don't need to stress too much about them. Estimating radicals is good for like a few reasons. It's good when you're just trying to like quickly check out answer and be like, is it close enough to what it should be? Especially when you move on to grade 10 and you start doing trigonometry. We'll do a little bit of trigonometry in this class too, but it's good to be able to be like, yeah, okay, it's kind of close to my answer, so I must be kind of right. And then you know you're ballparking generally close. We got 3 examples right here. I want you to try to estimate them without your calculator. So try to put what you think square root of 20 would be close to, what square root of 53 would be close to, and what negative square root of 33 would be close to. So you got a couple minutes. Okay, so if I was to estimate 20, 20 is in between 16 and 25, and it's almost like perfectly in between 16 and 25. Therefore, the square root of 20 should be almost perfectly in between the square root of 16, which is 4, and the square root of 25, which is 5. So, Akai, what do you think would be a good estimate?
Around like 4.3.
I like that. So if you put 4.3, that should work. You want to be closer to 16, so closer to 4, because 20 is closer to 16 than 25. I personally probably would have put 4.4. 4.3, 4.4, 4.5, all would have been answers I probably would have accepted. 4.6, maybe you're pushing it. 4.2, you're probably pushing it. Right? So you're trying to get somewhere close in that range. If you're looking at square root 53, anyone want to offer an estimate for square root 53? Yeah, Drake.
So it would probably be 7.5.
Yeah, so you're probably getting pretty close. So you're looking at 53. 53 is in between 49 and 64. It's closer to 49. So when you're picking your decimal, you want to be closer to 7. I would probably go with 7.3, maybe 7.4, 7.5 would work. 7.2, I'd probably accept. 7.1, I'd probably accept. But 7.6, 7.7, things that are over the halfway mark, I'd probably not accept it. 7.3 is dead on?
7.28.
Yeah. So, I mean, that'll round up to 7.3, which would work. The last one, E, when you're looking at estimating a negative number, all I want you to focus on is the root. So if I'm trying to estimate root 33, anyone want to offer up something for root 33? Yeah. 5.7? So, yeah, and I'm just worried about the root for now. So if I'm doing root 33, 33 is in between 25, 36. It's closer to 36. So my decimal should be in between 5 and 6, but be closer to 6. So he went with 5.7? 5.7. Yeah, and because that turns into 5.7, the negative will still be there as well. So it's negative 5.7. Right? The negative is not part of the root. Kind of like the negative wasn't part of the base when we didn't have the brackets around it. Same kind of concept. That negative is out front. It actually represents negative 1 times root 33, which is why it turns into negative 5.7. Awesome. I think you guys are getting estimating roots. To estimate roots that are fractions, we do the same thing. I'm going to show you a little bit of a trick to help. It's also a trick that will apply moving forward in mathematics. Yeah. So if you look at estimating a root, yeah, go ahead.
Sorry.
So if you look at estimating a fraction, you're going to use your math rule, which will be useful in math 10 and more mathful in math 20, that when you have a fraction under a root sign, you can break it up to be two different radicals. So I can break this up to be square root 23 and square root 80. Then I can estimate root 23 and I can estimate root 80. And you do it as two separate things. You're going to do the top and you're going to do the bottom. Kind of like when we were multiplying with exponents, right? Multiply the tops, multiply the bottoms. For this, square root the top, square root the bottom. And you're just estimating. You're not actually calculating. So if I wanted to square root 23, 23 is really close to 25. It's a little bit less. So instead of it being 5, it should be a little bit less. So I'm going to estimate that root 23 would be really close to, I want to do it in red, sorry. Let's say 4.8. And on the bottom, root 80, 80 is super close to 81. So I want my root of 80 to be really close to 9, but a little bit less. In this case, I'm going to say that it's 8.9. And that would be my estimated root. Below, they've kind of described that, right? So we're going to fill in the blank a little bit. It says 23 is close to the perfect square of 25. And 80 is close to the perfect square, 81. Therefore, we can break those apart, and we're going to come with 4.8 divided by 8.9. Okay, so when you have a fraction, just split it into two separate questions. Kind of like multiplying with your exponents. Okay, for B, we're going to do the same thing.
What was that question?
4.8 and 8.9.
2.3.
What?
7.6.
No, you should have been filling out while we're doing it, man. We can't just always be coming back for you guys.
And 4.9?
Yeah. So if you look at the next one, we have root 8 divided by root 17. The way we tackle that is we break it into two. We're going to have root 8 divided by root 17. 8 is really close to 9. 17 is really close to 16. Therefore, their square root should be really close as well. So when I go to square root it, root 8, I'm going to say is 2.8. Root 17, I'm going to say is 4.1. And that gives me my estimated radical for a fraction of 2.8 over 4.1. Cool. There's 3 right there, all fractions. I want you to give it a shot. Okay, estimating these fractions. Our strategy for estimating fractions is to break it into two estimations. So I'd break this into root 5 divided by root 27. Who wants to offer something for root 5? There. 2.1 seems wonderful to me, right? The reason I chose 2.1 is because it's slightly bigger than 4, right? 5 is a little bit more than 4. So therefore, the square root of 5 should be a little bit more than the square root of 4. So 2.1. The square root of 27. Nick. 5.2. I like it. Therefore, the fraction would be close to 2.1 over 5.2. If you have something different, that's fine. So if you have 2.2 and 5.1, that's cool. If you have 5.7, right, that's where it's a little concerning. You're too far away. You have to be somewhere within a couple decimal spots. For D, we would do the same thing, split into 2. Anybody want to offer up their answer as a fraction? Joey. 7.9 on the top? 10.2 on the bottom. I like it. You got 7.9 because the square root of 61 is getting really close to 64. Square root of 64 is close to 8 or is 8. So therefore, my root of it should be really close to 6 or really close to 8. Same thing with 104. 104 is a bit more than 100. Therefore, the square root of 104 should be a bit more than the square root of 100, which is 10. That's where I got 10.2. Okay. Yeah, next one. What do you got?
I did 6.2 or 3.
6.2. I like it. Divided by?
6.6 or 7.
6.7. I like it. Okay. The way he got that, 39 is close to 36. Square root of 39 should be a little bit more than the square root of 36. So 6.2 makes sense. If you needed 6.1, perfect. 6.3, perfect. 46. 46 is really close to 49, a little bit less. So a little bit less than 7 would be 6.7. So that's a wonderful answer as well. The negative in front of the radical still needs to be in front of my answer. So my answer would be negative 6.2 divided by 6.7. Wonderful. Where this might be useful is when you're estimating the side lengths of squares. So remember yesterday, we had learned that if you want to convert in between area and side length, we used area equals length squared as our little cheat formula. That means that the square root of an area will equal my side length. So if you ever have a square and you know the area and you're trying to figure out the side length, you could estimate it really quickly without actually having to calculate it by just square rooting your area. The way we see that like pictorially, we have these squares right here. We have 3 in there. We have the smaller one, which is 16. We have the biggest one, which is 25. And then we have the in-between, which is 20. If you wanted to figure out the side lengths for each one of those squares, the side length for 16 would be the square root of 16, which is 4. If you wanted to figure out the big one, the square root of 25, square root of 25 would be 5, which is the side length of that big square. To figure out anything in between, you're estimating the exact same way. 20, oh, I need a bright color. 20 is a little bit closer to 16 than it is to 25, but it's pretty well in the middle. So the side length would be root 20, which is pretty close to, I would say, 4.4 or even 4.5, right? Estimating. It's a quick way to see what a square would actually be as a side length. We're going to do some questions on that. So they've explained that here, right? With their little graph, they put 20, 25 in there. They got 4.5 as their halfway point. This should be a little bit less. I want you to estimate the side length of a square that's 7 square units. Put your answer here. So try to estimate the value of that side length. So I'll give you a second just to put that in. So example 3, it says estimate the value of root 7 to 1 decimal place. 7 is really close to 9. Square root of 9 is 3. So the square root of 7 should be, I don't know, let's say 2 point, well, it'll be less than 3. right? Because 7 is close to 9, but it's a little bit less than 9. Would you put 8? Yeah.
No, I put 6.
You put 6? Yeah, that works. So your answer should be a little bit less than 3, because the square root of 9 is 3. 7 is less than 9. You went the other way. Yeah. Yeah. No, I didn't. Example 4. Example 4 is going to bring in the definition of rational and irrational. So you did learn, I believe in grade 8, these two definitions. A rational number. A rational number is a number that stops. So for instance, like the number 2 stops. The number 2.1 stops. Number 2.123 stops. We call it a terminating decimal. Like that's the mathematical term for it. But a rational number just means it ends at some point. An irrational number goes forever. That would be like 2.1234972, and it just keeps going forever and ever and ever. The only numbers that can get kind of tricky that this rule doesn't follow is numbers that repeat. So for instance, you know how sometimes in your calculator you'll get like 3.33333333 and it's repeating? That counts as a rational number even though it never ended. So we say it repeats or ends. Numbers that go forever and never repeat are irrational. Typically, you get irrational numbers by square rooting non-perfect squares. Sometimes there's some that work out, right? That you square root a weird number and it still comes out as a rational, but those are pretty rare. The only ones that typically come out nice are your perfect squares. So we're going to do a few together just to see what they come out as. So if we look at the square root of 80, if I was to square root 80, which on your calculator you do hit 80 and then the square root symbol, the square root of 80 would be 8.94427, and it keeps going. And notice how there's no pattern, right? It's just going. Because it has no pattern and it never stops, we call that irrational. If you look at B right below, we're trying to figure out if square rooting that would become irrational. You're square rooting a fraction. So how do we square root fractions? Top and bottom separately. So if the top and the bottom both come out nicely, then that would be a perfect one as well. If one of the top or the bottom came out irrational, the whole thing's going to turn irrational. So looking at this, the square root of that would become 11/6. Both are perfect square roots. Therefore, this is a rational number. If you tried it in your calculator, it might come out irrational, which is why it's important to understand how to actually just calculate it on your own. If you look at C, you have 49. The square root of 49 equals 7. That's a rational number because it ends. Yeah. Yeah. Did you put rational? Yeah. If you look at D, we're square rooting a fraction, so we want to square root the top and bottom separately. The square root of 50 is irrational, 7.07106, and it keeps going. The square root of the bottom number, 75, is 8.66025, and it keeps going. If one of the top or the bottom is irrational, the entire thing's irrational. Those are questions that you can actually put in your calculator to figure it out. It's not asking you to estimate. It wants to know, is it rational? Is it irrational? Awesome. Number 5. We're just going to do some estimating with number 5. So number 5 is between what two consecutive integers does the irrational number fall?
7.
If you want to do that, you're going to actually calculate that. So figure out what it is. If you do square root of 42, you get 6.48 blah, blah, blah. The two numbers that it falls in between would be 6 and 7. So it's basically why you could use estimating rather than having to actually calculate it. It's saying what two numbers does it fall in between. You could calculate it and figure it out, or you could just estimate it and figure it out really quickly in your head. So for instance, if you look at B, instead of actually calculating B, the negative root of 135 would be somewhere close to the negative root of 12 point something. Let's say 12 point, 11 point. Let's say it's 11.6. Therefore, it would fall in between negative 11 and negative 12. Yeah, that'd be the estimate of it. Yeah. Okay. For example 6, I want you to try it on your own. You're just going to write the closest estimate that you can get for those things. What number is it closest to? So it's not asking for the decimal. It's asking what number is it closest to. For instance, root 23 should be closest to 5. And that's the integer that it would be closest to. Okay, so root 70. Root 70 would probably be like 8.2, 8.3, somewhere in there. That means the closest number it would be to would be 8. 95 is closest to 100. So the square root of 95 would be really close to 10. In this case, negative 10, because there's a negative out front. The next three, we're doing the same thing. We're just estimating. So my guess is that root 18, estimate the square roots of the irrational number. So we're going to say square root of 18 is going to be like 4.2. 4.1 would work too. 62 is really close to 64. Square root of 64 is 8. That means I'm going to go with like 7.8.
What about 7.7?
7.7 works.
10.9.
90, really close to 81. Also really close to 100. Almost perfectly in between. Right? A little closer to 9. Because it's a little closer to 81. So if I had to guess, I would say that's probably negative 9.4 something. I'm going to say 4.5. So you could start to add on more decimals if you wanted, right? Because you're like, well, it's probably in between 9.4 and 9.5. So you could even estimate the next decimal place to get a little bit better at your estimations. Last question. A square garden has an area of 76. What are the approximate dimensions of the garden? Dimensions means length and width. It's a square garden. I know that the root of an area equals the length. Therefore, the square root of 76 would equal my length. And I'm just estimating because it said approximate. I'm really close to 81. So I'm going to say it's like 8.8 is my length. 8.7 is probably even better. Yeah. And the length and the width would be the same because it's a square. So if you put width is 8.8, same idea. the dimensions should be 8.8 and 8.8. Or 8.7 and 8.7. As long as you put the same number for both. Cool.